Let's do a quick example that involves no calculator. So here we have a function that describes the position of the particle moving along a horizontal line where time is positive. So that's what that's telling me. At which values of t is the particle moving to the right? So I know that a particle is moving to the right when velocity, or actually I don't want to call it v of t because I know that I'm going to need to take the derivative when x prime of t is greater than 0. Because if we think back to the very first video that I made, if I have my position function, I can take the derivative. That's going to give me my velocity. To figure out where it's moving to the right, I need to see where velocity is going to be positive. So let's go ahead and do that. Okay, so I know x prime of t, I'm going to need some power rules here. So this becomes 9x squared minus 24x. Okay. So I have found x prime of t. The next thing I want to do is factor. So x prime of t is going to give me 2. I can divide everything in this function by 3x. So if you're someone, here's a visual for that. Okay. So I get x prime of t equals whatever I factored out is going to come out here. And then I get 3x on the inside minus 8. Okay. So then the next thing I need to do is figure out my critical points. So my critical points happen when this whole function is set equal to 0. So I'm going to set each factor equal to 0. I get 3x equals 0 and 3x minus 8 equals 0. And to figure out what my critical points are, I need to solve for x for both sides. So one of my critical points is going to be at x equals 0, and I got that from this one. My other critical point when I solve for 0 here is going to be x equals 8 over 3, because I'm going to add 8 to both sides. I get 3x equals 8, and then I divide by 3 on both sides. So that's how I got 8 over 3. So here are my two critical points. The next thing I need to do is make a sign chart. So let me make a sign chart and put in my critical points. So 0, and actually I don't even need to go to the left of 0 because time is always going to be positive. So one of my critical points is at 0, and then my other critical point is at 8 over 3. Okay, so I need to know what's happening in this interval and in this interval. So I'm going to test the number 1. Let me take a green pen here. So I'm testing 1. And I'm going to put that into my velocity function, so the derivative. So if I plug in 1 into this factor, I get a positive number. If I plug 1 into this factor, I get a negative number. So this whole interval is negative. Okay, let's do the next one. If I plug, actually, no, I don't want to plug. I want to test. I want to test something like, I don't know, 10. Okay, so if I plug in 10 into here, I get a positive number. If I plug 10 into here, I get another positive number. So this whole interval, everything to the right of 8/3 is going to be positive. And that alone tells me what I need to know to answer the question. So we can say that the particle moves right for all of time is greater than 8/3 because x prime of t is greater than 0. Awesome. Okay. At which values of t does the particle change directions? So for here, we are looking for a sign change. The reason we're looking for a sign change is because if we remember back to this table, when velocity is positive, it's moving right. When velocity is positive, it's moving right. When velocity is negative, it's moving left. So at 0, whenever we've got that sign change, that tells me that I've got a change in direction as well. So there's a sign change at 8/3, at time equals 8/3, because the sign changes from negative to positive. So we would say, go red here. So at t equals 8/3, the particle changes direction because x prime of t changes sign from negative to positive. Okay. If they're asking me about acceleration like they are in part C, that means I need to find x double prime of t. So I need to take the derivative of the derivative. So let's see, x prime of t was 9x squared minus 24x. That means x double prime of t is going to be 18x minus 24. And if I'm trying to figure out what the acceleration is at 2, I can just go ahead and plug that in. So x double prime of 2 is going to give me 18 times 2 minus 24, which is going to give me 12. Okay. Is the particle speeding up or slowing down at 2? Well, I know that 2 is within this interval over here for making my sign chart. So I know that x prime of t, or I'm sorry, not x prime of t, x prime of 2 is less than 0 because that tells me the velocity. I know x double prime of 2 is greater than 0 because I got 12. 12 is a positive number. That tells me the acceleration. Okay, so now because these are opposite signs, I can say that the particle is slowing down. So particle is slowing down at time equals 2 because x prime of 2 is less than 0 and x double prime of 2 is greater than 0. The signs are opposite. Okay, thanks for watching. Enjoy your snow day.